Okay, guys, so we are going to be factoring to solve quadratic equations. So this is kind of putting the two things that we've been doing together, okay? So there's always going to be two solutions or two possibilities whenever we are factoring quadratics, okay? So this problem says, what are the solutions of the equation 4x plus 1 times x minus 2 equals 0? So this used to be a quadratic problem, and they've already factored it out and got the two binomials. So this is like saying a times b equals 0. And if a times b equals 0, then that means that a equals 0 and b equals 0. So what we do to set this up is we take 4x plus 1 and set it equal to 0, and we take x minus 2 and set it equal to 0. So basically you have yourself two tiny little math problems that we have to solve, and then those are going to be our solutions. So this one we add 2, so we get x equals 2. That's one possibility for a solution. Divide by 4, so we get x equals negative 1/4. So our two answers to this problem are x equals 2 and x equals negative 1/4. Let's look at another one. Come on. All right, let's look at this one over here. So we have x plus 1 times x minus 5 equals 0. So we're going to take x plus 1 equals 0 and x minus 5 equals 0 and solve. Yes, you have to show me setting up those problems and show all of your work for all of these problems. So our two possible answers are x equals negative 1 and x equals 5. All right, one more like that. So go ahead and pause it and try this one on your own. See if you come up with the correct answers. So you should have 7n minus 2 equals 0. So add 2. We get 7n equals 2. Divide by 7. We get n equals 2/7. Leave that in fraction form, guys. Do not change that to a decimal. We add 4. We get 5n equals 4. Divide by 5. So we get n equals 4/5. And leave it as a fraction. Do not change it to a decimal. All right, so that is how you solve them if they are already factored for you. Now we're going to have to actually factor first, okay? So guys, these are the same rules that applied last week when we learned factoring. So this one does not have an a value. So our rule is factors of c that add up to b. So 3 and 5. So since there's no a value, we can go ahead and break apart the x's, put a 3 in one, and put a 5 in the other, and set it equal to 0. And then you're going to solve. So x plus 3 equals 0, and x plus 5 equals 0. So we get x equals negative 5, and we get x equals negative 3. As always, guys, if I'm going too fast, you can pause the video, go back and rewatch something. Okay, but this is all just kind of combining what we did on that first slide with what we did last week. I'm going to go ahead and skip to one that has that a value, just so we remember how to do it when we have an a value. So the first thing we're looking for is whether or not we can take something out. And we can't, because 2 is an even number and 15 is not, okay? So this is where we multiply 2 and 18 to get 36. So factors of 36 that add up to negative 15. Okay? So we need a positive factors that add up to negative. So 1 and negative 36, negative 2 and negative 18, negative 3 and negative 12. So then we break apart. So we have 2x squared minus 12x minus 3x plus 18 equals 0. Remember, we then group the first two terms and the last two. See what we can pull out. So I can pull out a 2x. I get x minus 6. And then I would have to pull out a negative 3 to get x minus 6. So then these become one binomial, so 2x minus 3 and x minus 6 equals 0. And then we have to solve those. So x minus 6 equals 0. We add 6. So x equals 6 is one solution. And then we get 2x minus 3 equals 0. We're going to have to move up here. So we get 2x equals 3. Divide by 2. So we get x equals 3 over 2. Leave it as a fraction. Leave it as a fraction. All right. Couple more. So on this one, you'll notice that you have to do some work on the front end, okay? Because it has to equal 0. So we have to add this 42 over to the other side, okay? So this is what I was talking about the other day when I said you're going to have to actually move that to the other side and set it equal to 0 first. Because then I need to factor out the polynomial, okay? So I get x plus 6 and x plus 7 equals 0. So our final solutions would be x minus 6 and x minus equals negative 7. All right, same thing on this one. It has to equal 0. So we're going to take 9b squared equals 16. Subtract the 16 over. So I get 9b squared minus 16 equals 0. Guys, remember this is one of the special cases. So we have to figure out the squares of 9, which would be 3. So those get a b. And then we need the factors. So obviously it's going to be 4. But remember, it has to cancel out the b's and it has to equal a negative 16. So you're going to need one 4 to be negative and the other 4 to be positive. And then you set both of those equal to 0 and you solve. So you should get negative 4 over 3 and positive 4 over 3. All right. I do want to show you one where you have to factor out a number first. So whenever you factor out a number first, you don't do anything with it, okay? So if I have 8a squared minus 4a minus 4 equals 0. So the first thing you should be looking for, guys, is can I pull something out of all these? And I can't. I can pull a 4 out of all of those. So I get 2a squared minus 1a minus 1 equals 0. And then you go ahead and find your binomials. Okay. So since this has an a value, you have to take 2 times negative 1. So factors of negative 2 that add up to negative 1. So negative 1 and negative 2 and positive 1 will add up to negative 1. So then we break this apart, 2a squared minus 2a plus 1a minus 1. So then we group again. So you can take out a 2a, leave it with a minus 1, and then we can pull out a 1, and it'd be a minus 1. So then we get 2a plus 1 is one binomial, and then a minus 1 is the other. Now, if this was our answer last week, we would have this 4 pulled out in front. When you solve for the solutions, you're going to ignore the 4. So you're still only going to solve the 2a plus 1 equals 0 and a minus 1 equals 0. That 4 doesn't do anything for our solutions. We don't need that in there. So you would get negative 1/2 equals a and positive 1. So hopefully that's enough examples. Okay, if you need to, go back and re-watch any part of this, but you'll have one of every type of problem like that on your worksheet. Okay.